Hey everyone, welcome back. I'm Alex.
And I'm Jordan. Today we have a really practical episode for you.
So, in our previous episode, we covered the 8 key components of effective learning: motivation, attention, prior knowledge, practice, feedback, memory, metacognition, and environment.
After the last episode, you might be asking yourself, okay, but how do I use this in real subjects?
Exactly. So, today we're taking those 8 components and applying them specifically to chemistry.
Whether you're in high school chemistry, college organic chem, or studying for the MCAT, this episode is for you.
Let's dive in, starting with component 1, motivation. Jordan, I'll be honest, when I took chemistry, I struggled to care about it.
I think a lot of people feel that way. It can seem abstract and disconnected from real life.
But here's the thing. Chemistry is literally everywhere. Once you start seeing it, you can't unsee it.
Give me some examples.
Your smartphone contains over 30 chemical elements. The battery is electrochemistry. The screen uses rare earth elements. When you cook dinner, you're doing chemistry. Caramelizing onions, that's the Maillard reaction.
I never thought about cooking as chemistry.
Baking is even more precise. It's basically edible chemistry experiments. Why does bread rise? Carbon dioxide from yeast fermentation. Why do cookies spread? Fat melting and proteins denaturing.
Okay, that actually makes it more interesting.
Fireworks have different colors because of different metal salts. Red is strontium, green is barium, blue is copper compounds.
So the first tip is to find these real-world connections.
Exactly. Ask yourself, why does this matter to me specifically? Pre-med students, chemistry explains how every drug in your future career works.
Environmental science folks, you need chemistry to understand climate change and pollution at the molecular level.
Find your personal hook. And set specific goals, not just learn chemistry, something like master balancing equations by Friday, or complete 20 stoichiometry problems this week with 80% accuracy.
All right, component 2, attention and focus. This is tough because chemistry requires serious concentration.
It really does. You can't half focus on chemistry. If you're scrolling your phone while studying reaction mechanisms, you're wasting time.
So what's the strategy?
Use the Pomodoro technique, 25 minutes of pure focused chemistry, no phone, no social media, then 5-minute break. Repeat.
What should each 25-minute block look like?
Be specific. One block for learning new concepts, another for drawing structures, another for practice problems. Don't mix everything together.
Single task within chemistry, too.
Right. When you're doing nomenclature, only do nomenclature. When you're practicing calculations, only do calculations. Don't bounce between organic and general chemistry in one session.
What about timing during the day?
Match difficulty to energy. Learn new concepts when you're sharpest, usually morning for most people. Save flashcard review and lighter tasks for when you're tired.
Okay, component 3, prior knowledge. This is huge for chemistry because it builds on itself.
Chemistry is incredibly sequential. If you don't understand atomic structure, electron configuration makes no sense. If you don't get electron configuration, bonding is confusing. If bonding is shaky, everything after falls apart.
So you have to build the foundation first.
Exactly. The sequence goes atomic structure, then periodic table basics, then bonding and Lewis structures, then stoichiometry, then solutions, then equilibrium, then thermodynamics, then organic chemistry.
What if someone jumped ahead and is now lost?
Go back. Seriously, find where the foundation cracked and rebuild. It's faster than struggling forward without understanding.
What about connecting new concepts to things we already know?
Analogies are gold in chemistry. Electrons filling orbitals is like people filling seats in a theater. They fill the front rows first before going to the back.
That's helpful.
Chemical equilibrium is like people entering and leaving a party at the same rate. The party doesn't empty or overflow. It stays balanced. Catalysts are like shortcuts through a mountain. You still get to the other side, just faster and easier.
I love these. Any more?
Ionic bonds are like magnets attracting opposite poles. Covalent bonds are like two people sharing an umbrella. Neither owns it completely, they share.
These make abstract concepts concrete.
Before learning any new topic, spend 2 minutes asking, what do I already know about this? Activate that prior knowledge so the new information has somewhere to stick.
Component 4, practice and repetition. I feel like chemistry is all about practice.
It absolutely is. You cannot learn chemistry passively. You have to do problems. Lots of problems.
Tell me about spaced repetition for chemistry.
Create flashcards for things like element symbols, polyatomic ions, solubility rules, common reactions. Review them using spaced repetition. Day 1, then day 2, then day 4, then day 7, then day 14, then day 40.
Apps like Anki work well for this.
Perfect for chemistry. Make cards with the question on front and answer on back. Include images of structures. Quiz yourself actively rather than just reading.
What about problem practice?
Use deliberate practice principles. Don't just do easy problems you're comfortable with. Target your weaknesses specifically.
How does that look practically?
Say you're struggling with limiting reactant problems. Watch an explanation video. Do 5 guided examples with solutions visible. Then attempt 10 problems without help. Check answers and identify error patterns. Redo the ones you miss. Then try 5 harder variations.
Progressive difficulty.
Exactly. Level 1 problems have all values given. Level 2 requires unit conversion first. Level 3 is multi-step. Level 4 is word problems requiring setup. Level 5 combines multiple chapters.
Consistency matters too, right?
30 minutes of chemistry daily beats 3 hours once a week, every single time. Component 5 is feedback. This is where a lot of chemistry students go wrong.
How so?
They do practice problems but don't check their work carefully, or they check the final answer but not their process.
So they might get the right answer for the wrong reasons.
Or the wrong answer and not understand why. You need systematic feedback. After every stoichiometry problem, ask yourself, did I balance the equation? Did I convert grams to moles correctly? Did I use the right mole ratio? Did I convert back to the requested units? Does my answer have reasonable magnitude? Are significant figures correct?
A checklist for every problem.
Until it becomes automatic, yes. I also recommend keeping an error log.
What's that look like?
A simple table: date, topic, error made, why it happened, and correction. For example, March 15th, molarity, forgot to convert milliliters to liters. Why? Rushed through the problem. Correction? Always check units before calculating.
You start seeing patterns in your mistakes.
Exactly. Maybe you always mess up significant figures, or you consistently forget to balance equations first. The log reveals your personal weak spots.
Where else can students get feedback?
Online resources like Khan Academy give immediate feedback. Study groups are great because you explain things to each other and quickly discover gaps. Office hours with professors, specific questions work better than just saying, I don't get it.
And being open to feedback rather than defensive.
Crucial. Every mistake is data showing you exactly what to work on.
Component 6, memory and retention. Chemistry has a lot to memorize.
It does. Element symbols, polyatomic ions, solubility rules, reaction types, organic functional groups, it can feel overwhelming.
So how do we handle it?
Mnemonics are your friend. For diatomic elements, remember, have no fear of ice-cold beer. H2, N2, F2, O2, I2, Cl2, Br2.
That's way easier than just memorizing the list.
For the activity series of metals, little children make a zealous idea for managing strange pets. Lithium, potassium, calcium, magnesium, aluminum, zinc, iron, nickel, tin, lead.
The sillier the better?
Absolutely. Silly and vivid sticks in your brain. You can also use the memory palace technique. Imagine walking through your house. At the front door, there's a giant H-shaped door handle. hydrogen. In the living room, helium balloons everywhere. In the kitchen, lithium batteries powering all appliances.
You're linking elements to familiar locations.
Your brain remembers spaces really well. Use that strength.
What about chunking?
Instead of memorizing individual compounds randomly, chunk by pattern. All alkali metals plus halogens form metal halides with a 1-to-1 ratio. Sodium chloride, potassium bromide, lithium iodide. They all follow the same pattern.
Learn the pattern, not individual facts.
Exactly, and use dual coding. When learning about molecular geometry, don't just read that methane is tetrahedral. Draw the three-dimensional structure. Use a molecular model kit if possible. See it, say it, draw it, build it.
Multiple codes for the same information.
And please sleep. Your brain consolidates chemistry knowledge during sleep. All-nighters before chemistry exams backfire badly.
Component 7, Metacognition, thinking about your chemistry learning.
This separates students who struggle from students who succeed. After studying a topic, honestly assess yourself. Can I explain this without looking at notes? Can I solve problems using this concept? Do I understand why it works, not just how?
The difference between recognition and real understanding.
Exactly. Reading your notes and thinking, yeah, this looks familiar, is dangerous. You might recognize it but not be able to reproduce it on an exam.
How do you test yourself?
The Feynman technique. Pick a concept like electronegativity. Explain it in simple terms as if teaching a child. Electronegativity is how much an atom wants to pull electrons toward itself, like a tug of war for electrons.
And if you can't explain it simply?
You found a gap. Go back and study until you can. Also, predict your quiz scores before you get results. If you predict 85% and get 72, you know you're overconfident somewhere.
Calibration.
Right. Keep a simple learning journal. What did I study? What made sense? What confused me? What will I do differently? You become a scientist studying yourself.
Component 8, Environment, setting up for chemistry success.
Have your tools within reach. Periodic table on the wall or desk, scientific calculator, molecular model kit if possible, colored pens for different elements, graph paper for drawing structures.
Reduce friction for studying.
If you have to search for your calculator every time, that's a barrier. Keep everything organized and ready. Also consider context-dependent memory. If your exam is in a quiet classroom, practice problems in similar conditions.
What about study groups for chemistry?
Incredibly valuable when done right. Structure it. Everyone prepares individually first, then each person explains one concept to the group. Work challenging problems together. Quiz each other. Identify topics needing more work.
Not just a hangout session.
Exactly. Social learning works when it's focused. Finally, take care of yourself. Sleep 7 to 9 hours. Exercise helps your brain function. Eat well. Manage stress. Your brain isn't separate from your body.
This has been so practical. Can we do a quick summary?
Absolutely. For motivation, connect chemistry to your life and goals. Find the fascinating angles. Set specific, measurable goals.
For attention, use the Pomodoro technique. Single task, remove your phone during study sessions.
For prior knowledge, build foundations first. Use analogies. Activate what you know before learning new topics.
For practice, use spaced repetition flashcards. Do lots of problems. Target weaknesses with deliberate practice.
For feedback, check your work systematically. Keep an error log. Seek help when stuck.
For memory, use mnemonics and memory palaces. Chunk information by patterns. Draw structures, sleep well.
For metacognition, test yourself honestly. Use the Feynman technique. Keep a learning journal.
And for environment, set up your study space. Use study groups effectively. Take care of your physical health.
Chemistry is challenging but learnable. Apply these 8 components consistently and you will improve.
Thank you for listening, everyone. If this helped, please share it with someone struggling with chemistry.
We'd love to hear your chemistry learning tips too. Reach out and let us know what works for you.
Until next time, keep learning.
Take care, everyone.